and welcome to this session, Genome Editing, Assessing the Threats to Agroecology. This is one of the last sessions of the day, so perhaps not the best time to sound a wake-up call or ring an alarm, but that's what we're going to do in this session. My name's Lawrence Woodward. I'm a director of Beyond GM, which is an initiative to raise awareness among citizens of genetic engineering technologies and alternatives to them. However, my working life, or most of my working life, has been spent in organic agriculture as a co-founder and former director of the Organic Research Centre. Genetic engineering technologies, and especially genome editing, are being hailed throughout the world as a game changer. It's said they will be profoundly transformative across farming, food, and environmental protection, including climate change. Yeah, for something that's so potentially powerful, so transformative, it's been accompanied by a push for deregulation, for loosening of the already weakened restraints of transparency and democratic control. It's our contention that genome editing and associated technologies pose a significant threat to agroecology, and all those people who are supportive of agroecology need to wake up and take notice of this threat. Now, we've posted an online survey aimed on the chat, aimed at collecting views on this threat, what you think about it. The details are in the chat. We hope you will look at that and fill in the survey so we can get feedback. We have three very eminent and knowledgeable speakers this evening who are going to give their insights ahead of a discussion, which, because of time constraints, will be a limited discussion. But what we don't get to in the discussion today, we'll pick up thoughts and comments from the chat and follow them up in online communication later. So our first speaker, who's going to outline some aspects of genetic technology, genome editing technologies, and how it might relate to agroecology, is Jack Heinemann. Jack is Professor of Genetics and Molecular Biology in the School of Biological Science and Director of the Centre for Integrated Research in Biosafety at the University of Canterbury in New Zealand. The significant, or one of the significant things about Jack, he's one of the lead authors in the 2008 very groundbreaking international assessment on agricultural knowledge, science and technology for development, the famous ISTED report, which discussed feeding the world with different technologies and concluded at that time that GMO technology had very little to offer in, quote, feeding the world, unquote, but that agroecology did. So Jack's, from these two perspectives, is an ideal person to kick off about the potential threats from to agroecology. Jack, please.
Well, thank you, and thank you very much for inviting me to the conference. I'd just like to say, good morning, afternoon, evening, depending on where you are in the world. As you can see, it's morning here, so it's a great time to kick off an issue like this from the New Zealand perspective. I will just start sharing my screen. There we go. Wonderful. So I can't see you, so I'm hoping that you can see my screen. Today's, I'm going to address the issue of how these so-called new techniques of genetic engineering, genome editing, and also gene silencing with uses of double-stranded RNA, those types of techniques, how they might work in a world that is an agroecological world. And the four main points that I'm going to try to make is that these so-called new techniques are not fundamentally new. And when we're considering the rhetoric, largely biochemical rhetoric about these techniques, we have to consider how they would change or alter what we might do in an agroecological agriculture. These new so-called techniques increase the capacity for human intervention into agriculture and into biology, and also because agriculture is a multifaceted enterprise of humanity, all our other kinds of socio and economic dimensions. These new techniques have a new feature, however, that does distinguish them as somewhat of a game changer from past technologies, and that is their ability to interface with people that allows any potential harm, should it be realized, to become harmful at a larger scale more quickly. Nevertheless, both agroecological agriculture and what we might call conventional agriculture that could use these kinds of genome biotechnologies exist in the world. The question is what that coexistence timeline should look like. And drawing upon the ISTAT, as Lawrence introduced, I'll be talking about that transition from what we have now to not a more sustainable agriculture, but to actual agricultural sustainability. The rhetoric around these techniques, of them being new, is itself a way to generate an impression about the techniques and to cause society to reconsider how they will interact with these new techniques. But the concept behind the new techniques is not old. This quote, the ignis fatuus of genetics, has been the specific mutagen, the reagent that would penetrate to a given gene, recognize it, and modify it in a specific way, was definitely the hope for many, many decades. This quote comes from Nobel laureate Joshua Lederberg in 1960. Really about 60 years before we had, or 50 years before we had these so-called new techniques. From reviews about gene technologies already in the 1980s, you can see that gene editing and directed mutagenesis were not new concepts. So commensurate with the Asilomar conferences in the 1970s and the development of a framework for regulating gene technology, there was already work going on trying to and successfully achieving gene-edited outcomes. Now, there were differences between the technology available in the late 1970s, early 1980s, and the technology we have now. And those differences are tool-based, different enzymes and different capacity to generate new DNA molecules in a synthesizer, but they weren't conceptually or qualitatively different. And over the decades from the late 1970s to about the turn of the century, gene editing techniques were being used in a number of different organisms, just not plants and agricultural animals as they can be now. One of the rhetorical responses is that the new techniques allow the recombination reaction to occur in vivo. And that is what distinguishes it from the in vitro techniques that dominated the types of transgenesis generating genetically modified organisms. However, that is a sort of blanket to cover up how these techniques have always worked. So these techniques have always involved an in vitro stage and an in vivo stage, where the recombination events that result in the new traits for these organisms occur and have always occurred within the organism itself. So all these techniques, except perhaps chemical and radiation mutagenesis, involve the preparation of nucleic acid molecules or nucleic acid molecules and protein molecules, which are then transferred into cells for the reaction to take place. So there isn't really a conceptual divide between the older forms, that is what we call the older forms, the transgenesis genetically modified organisms, and those that are forecast using these new techniques. But as I mentioned, the new techniques do have new features, and those new features are in a continuum amongst the features of human technologies that allow them to be used at greater and greater scales. So we could imagine, for example, the technology of the screwdriver to drive screws into some substrate. The new techniques don't change that fundamental concept of what a screwdriver does, but they allow more screws to be driven more quickly than when we had to hold the screwdriver. That old screwdriver had a set head, so it could only interact with some kinds of screws. The new technologies allow an interchangeability of heads, and this is the range of organisms that can be modified using these techniques within the same period of time. So the scale here is number of organisms and perhaps number of environments in which we can start to work with these technologies. And if we draw upon the idea of screwdrivers making incremental changes as well as scale changes, if we look at Doctor Who's sonic screwdriver, how does that differ from what we now have on Amazon, which is mass-produced sonic screwdrivers? Well, the difference is that at one time, sonic screwdrivers were retained for use only by highly specialist technicians and under controlled conditions. The new techniques allow genetic engineering to be conducted at different environmental scales and also different social scales, with the tools for these techniques available across the spectrum of users and most of the, if not all, of the necessary components to make these reactions happen available over the internet. What the ISTAT, I think the critical point that the ISTAT made is that agriculture is an interconnected activity of humans and can't be discussed simply as a laboratory experiment in the same way. When we make changes to the science involved in agriculture, we also make changes to how that impacts all sorts of socially created frameworks, including intellectual property, the distribution of intellectual property among different nations and different users. The ISTAT was an exercise to achieve agricultural sustainability. And what it identified was that there are high productive systems, conventional systems that are unsustainable, and there are low input systems that are unsustainable. And we want to move practitioners of both of these systems to sustainability. The argument is that these new techniques can coexist with agroecology and help us to move to a sustainable system. It is not expected by the ISTAT, however, that wherever these systems coexist, the agent of transition must also become part of that sustainable future. So the coexistence idea for these gene technologies is where they have already been adopted, being useful to finding an ultimate solution, which is far more aligned with agroecological agriculture, and not that agroecological agriculture is aligned with these new techniques. So if you're interested in some background information, I recommend these sources, and I look forward to hearing from the other panelists. Thank you very much.
Thank you, Jack. That's very good, and lots of real challenging questions lurking below that, which hopefully we can bring at least some of them out. Our next speaker, with the title, Can We CRISPR Agroecology? is Dr. Maiwa Montenegro DeWitt, who's an assistant professor in environmental studies from the University of California, Santa Cruz. And her work spans the development of new biotechnologies such as CRISPR and the impact, how they impact on transitions to agroecological food systems, food and seed sovereignty. Maiwa, please.
All right, are you seeing my slides okay?
Yes.
All right, thank you. I'm so pleased to join you all today. Jack had some really excellent background from a biologist perspective, which I really appreciate. I'm going to bring a bit more of the social science side. And the first thing I'd like to do is acknowledge the extraordinarily wide range of phenomena that we could be potentially talking about today under the general umbrella of risk when it comes to CRISPR and agroecology. So, for example, at the molecular scale, there are now dozens of studies reporting off-target effects, large chromosomal rearrangements, incorporations of vector material into final products, such as cattle. And as my colleague Jack has pointed out, we actually know very little about how the effects of mutation events transform when they are not actually relatively infrequent and slow as in evolutionary processes, but when we intentionally introduce them at scale. At the ecosystem level, we could be talking about disruptions to entire communities of plants and animals in agroecosystems when technologies such as CRISPR-based gene drive are brought in to intentionally eradicate populations through rapid propagation in the wild. So they may be brought in under the assumption that certain populations are so-called pests, but doing so in the absence of understanding the complex and cascading effects throughout trophic or food webs. And the question here is, I think, what do we know about the effects of so-called precision when it comes from thinking beyond individuals as isolated units and in terms of interrelationships in real agroecosystems? Shifting to consider the political economic scales, we could be asking about risks in terms of accumulation and corporate control of plant genetic resources. So, to their credit, many advocates and proponents of CRISPR have advocated for open access, repositories such as AdGene, and for open licensing of non-commercial research. Yet already in 2016, it was apparent that the patent and licensing landscape for CRISPR was shaping up along very familiar contours, right? And by 2019, as you can see in this graphic, a majority of CRISPR intellectual property was owned by Corteva's subsidiary Pioneer Hybrid and by Monsanto Bayer, two of the world's largest agrochemical firms. Now, these risks are very real and are worthy, I would say, of much more research and public dialogue. Yet I'd also like to argue that the risk framing itself is fundamentally too narrow for our purposes. So in the words of science and technology scholars Phil McNaughton and Michelle Habets, technologies have been promoted on economic grounds, with the market as the arbiter, with regulation viewed as a technical consideration, conducted by case-by-case scientific risk assessment that address specific harms to health and the environment. Thus, from the outset, questions concerning socioeconomic, ethical, and wider ecological impacts of the technology have been excluded as bona fide questions within that strictly risk-based regulatory framework. So that is really my first agroecological invitation, is to invite us to step outside the narrow risk framing and into a wider socioecological and relational view. Now, this lens also calls attention to indeterminate histories, which when revisited, I'd say often reveal multiple pathways that were untaken. One such story I'd like to briefly relate with you is that of the Biological Control Research Station at the University of California. Now, this system once had its own departments, facilities and faculty at UC Berkeley, UC Riverside, and UC Davis, combined with a large experiment station at the Albany Gill Tract. You can see a map here from the 1940s. And from the 1920s, roughly through the 1970s, this infrastructure generated scientific evidence of effective biological pest control, produced numerous graduate students who became research leaders at other universities and at government agencies, and it generated demonstrable economic benefits for the state of California, including controlling what would have been an otherwise devastating citrus disease outbreak. Yet, hand in glove, as many of you may know, in the 1970s, alongside the neoliberal turn, biological control, along with other applied biology departments, was slowly dismantled in favor of investments in molecular biology and genetics. And this has been widely documented, including by the late sociologist Fred Buttle. The Gill Tract itself, a contested piece of land in Albany, has been mostly sold off by this point for private development, save a small portion that remains in the hands of the community for a farm. Now, this systematic defunding of US research that threatens the objectives of industrial agriculture has been seen more recently. A study by DeLong and colleagues in 2016 found that the total USDA budget, US Department of Agriculture budget in 2014 was approximately $157.5 billion. And of that sum, a mere 12 million, M with an M here, not the billion, went into projects with transformative agroecological potential, meaning combining aspects of both social and ecology. By contrast, the Innovative Genomics Institute at UC Berkeley and UC San Francisco alone invested $125 million beginning in 2017 to expand UC's gene editing research into food crops and microbiomes. And I should underline that that is just a drop in the bucket. So according to the US Congressional Research Service, the NIH, the National Institutes of Health in the US, spent roughly $3 billion between 2011 and 2018. My second invitation, therefore, is that we tell these stories, that we revisit these path dependencies in which certain regimes of knowledge have gotten constructed and strengthened over time, while others were undercut both financially and culturally, and thus delegitimated. So by looking at these histories, I'd say we can better appreciate those path-dependent processes and why certain areas can be locked in, such as genetic engineering, while others, such as agroecology, have been systemically locked out. Finally, CRISPR has been described as superior to GM technologies in being faster, cheaper, more precise, and functional in a wide array of species, as Jack commented on. As such, it's been suggested that researchers will quickly move beyond the canonical crops like soy, canola, and corn, and go on to gene edit crops like cassava and cacao for the benefit of subsistence farmers, particularly in Africa. Now, given globally recognized concerns about crop genetic erosion, one might say that that is of benefit. Yet indigenous communities are wary of several potential pitfalls based on their experiences. So I will just share a few of these. Some are quite old in their content. They're concerned still about the displacement of native and traditional seeds as farmers are encouraged to adopt so-called improved gene-edited varieties. There is deepening concern about the appropriation of indigenous cultivars and wild relatives, especially as wild relatives in more distant areas of the gene pool become newly mineable to develop CRISPR crops. In turn, there is concern about gene flow from edited organisms back into land races and crop wild relatives, a topic particularly sensitive in and around crop centers of origin and diversity, such as highland Peru, as you can see here, the Hindu-Nepal region, the Yucatan Peninsula, and others. At the landscape level, there are concerns about shifts to monoculture methods, meaning that the issue here is not merely the replacement of one variety with a gene-edited variety, but the management that leads to system-wide loss of crop genetic diversity, and along with that, ecological resilience and traditional livelihood strategies. With monoculture, we frequently see lock-ins to larger input and agrochemical packages, such that we might find that gene-edited crops become touted as safe for consumers, especially in more wealthy parts of the world, yet remain costly in terms of local pesticide exposure, debt burden, and environmental pollution. And last but not least, there's risk and concern about de-skilling and loss of seed and agroecological knowledge, which for Indigenous peoples has always been deeply connected to language, customary laws, and cultural identity. So making all of these concerns more urgent and often less palpable is the combination of biotechnology and big data. So new challenges are arising as seed information can be commodified without access to or exchange of biological material itself. And although it's important to say that seeds and genetic material can never fully be replaced by mere data, the so-called process of dematerialization is a mounting concern for Indigenous communities who have long experienced the appropriation of their seeds without permission or just compensation. So my third and final thought is to take a step back to appreciate the longue durée view. Indigenous peoples and smallholders are the planet's first plant breeders and can be credited with developing the crop genetic diversity that supports the food system and all gene editing today. So what does the CRISPR question look like from the world's most enduring experts? And thank you.
I feel I need to just highlight, someone said, should the question, is gene editing a threat to should the question be, is gene editing a threat to agroecology? And there was a little slap over the wrist there. Please do not start with the answer and then have a debate pretending to assess the risks. Whether it is a threat or not a threat is something we might touch on in the discussion. And of course, Miwa raised the issue about what is a threat and what is a risk depends on how you frame these things. That's a lot to get into in the limited time we've got. But maybe Pat will enlighten us a little bit on that. Pat Thomas, my colleague on Beyond GM, is an award-winning journalist, author, and campaigner. And she is going to argue that we need a plan to respond either positively or negatively to genetic techniques, to genetic technologies. Pat.
Thank you, Lawrence. And thank you, Myra and Jack, for covering an assessment of some of the risks from a scientific and on-farm and social perspective. I'm looking at a different risk, one that's probably not quite so popular with the audience that we have today, but let's give it a go and see what happens. Support for agroecology is support for a system where food is produced sustainably and has a transparent provenance. That's what we all want. That's the beyond part of Beyond GM that we aim to promote, and it's something we believe in and feel positive about. But it's not going to happen by positive thinking alone. Unfortunately, I think there is a tendency within the agroecological movement to believe that we have right on our side, then that the passion and commitment that we have is enough to bring people along to create momentum that will see the agroecological approach prevail. And positivity, of course, is important, but it isn't a plan. And if we are going to see agroecology scale up, we need a plan. And part of that plan is a realistic assessment of the vulnerabilities of the movement and of agroecology more generally. All over the world, including here in the UK, we are in a delicate position. A period of transition where governments and others who hold power are considering how they will reshape agriculture for the future. And I have to tell you, it's not looking great. We are hearing all the right words: sustainable, green, climate, future generations, exhortations to work together for the greater good. But the plan is still very much an industrial model of agriculture in which technology, particularly genetic engineering technologies, take center stage. In the UK this week, the government launched a public consultation on the deregulation of genome editing, which, if it delivers what the government hopes it will, we'll see labeling and pre and post market monitoring removed from some of the products of genome editing in England and eventually the rest of the UK. Environment Secretary George Eustice said at the launch of the consultation that gene editing harnesses the genetic resources of Mother Nature, and in so doing can produce crops that perform better, reduce costs to farmers and impacts on the environment, and of course, fight climate change. Let me be blunt. Agroecology doesn't feature anywhere in the UK government plans for the future of farming, except as maybe one of the many tools in the toolbox. Agroecology is not central to the National Farmers Union plan for the future of farming. Genome editing is. And it's not even clear whether agroecology will be the foundation upon which the upcoming National Food Strategy report will recommend that we build the future of farming. And it may not feel like it when we gather together at conferences like this, but we are falling behind. We are losing the PR battle. We are losing the funding battle. We are losing the political battle. And so it is a puzzlement to me that many of my colleagues in agroecology seem to acquiesce to this falling behind. It's a puzzlement to me that we are not all working together to address the way that technology, and especially perhaps genetic engineering technology, has been centrally positioned in the green and sustainable agriculture narrative. And it is being used to quietly reinforce existing lock-ins that keep us in a destructive industrial system. This lack of engagement was really brought home to me last year when Beyond GM conducted a series of surveys of food and farming groups to better understand what they understood about genome editing. First of all, we had a hard time getting people to respond. Many groups that we contacted felt that genome editing was way outside their remit or that it wasn't a priority for their supporters or members, but we persevered. And the results indicated that amongst the UK's food and farming organizations, there's a new dynamic at play. This sector itself is less cohesive, less engaged, much more hesitant to be critical of genetic engineering than it was in the very recent past. Nearly half of the responding organizations had no official position on genome editing at all. The largest number of respondents favored a moratorium, but there was no indication that they understood that moratoriums must end. And then what? A significant number thought that genetic engineering had potential in tackling global agricultural changes. There was support for government-based regulation, labeling, and ongoing monitoring, but the unexpected reluctance to concede that the public should have any role in decision-making around genome editing. And this lack of engagement matters. And now in the UK, with this public consultation, we have a perfect and pressing example of why. The consultation itself is not very people-friendly. It asks not very easy questions about complex subjects and asks further that respondents provide evidence to justify their points of view. In other words, it's canvassing not just opinion, but how engaged people are in the subject, how likely they are to be able to put up a good fight. And when I spoke here last year, I referred to that process as testing the fences, seeking out the other side's weaknesses. If your organization does not have a well thought out policy around genome editing, you are not going to be able to put up a good fight. If you can't help your supporters or members fill in the survey effectively, they are not going to be able to put up a good fight. Now, nobody would expect all the diverse kinds of groups working in this field right now to make genetic engineering a central priority of their work. But just as we need to understand the basics of how pesticides and fertilizers impact agriculture, we need to understand where genetic engineering, particularly the diverse new types of genetic engineering, is driving us. And we need more advocates who can help us in our mission to move beyond the narrow thinking and short-termism of techno-fixes. And this is why over the next year or so, Beyond GM will be collaborating with our colleagues at GM Freeze on a piece of work that seeks to understand why the agroecological community is so reluctant to get involved in this discussion, but also to find out if there are any routes to greater involvement. Excuse me. We'll be hosting events and offering groups in the UK bespoke staff learning sessions so that we can provide insights into the way that genetic engineering technologies have progressed in recent years, but also so that we can listen to their concerns and get more of a regular dialogue and a plan going on between us all. It's a first step. We hope you'll take it with us. I'm going to leave it there. There's a few links that I've posted for all of you if you want to sort of take the poll that we've got running at the moment about what you think the challenges to agroecology are, and a few other links beside. So, you know, and also if you're interested in taking part in one of those sessions, please contact me directly. Thank you.
Thanks, Pat. A number of quite interesting things coming up on the chat, including people asking questions about is there potential benefits of genome editing that could be of benefit to agroecology. Jack, can I ask you, the ISTED report signed by however many countries, 140 countries or something, drawn up by all the international agencies, dealing with the issue of technology and how to feed people, concluded that there was a limited role for GMOs, old style GMOs, and that the potential of agroecology to feed the world in a sustainable, equitable way was massive. That, for various reasons, that report was barely acted on. But the question I'd like to ask is, first of all, the report did not say that GMOs should be banned or prohibited. It basically said it's got a limited role and implied there would be some coexistence between agroecological approaches and GMO approaches. GMOs would probably fade away. Now, with the new technologies, with the greater potential impact of scale and the tools as you outlined in your talk, would you draw similar conclusions about the new genome editing technologies, or do you see them as a more potent approach, more damaging approach to agroecology, ecological approaches to production and feeding the world? Do you see, would the conclusion be the same, or would it be different?
It's difficult to project, I mean, because we are in early days. The ISTAT report had the advantage of being able to look backwards for, you know, over 100 years and had the collective benefit of hundreds of researchers contributing to it. And the new techniques, or at least their application in agriculture, is recent. So we don't have quite the evidence base. However, nothing that I've seen in the literature suggests that how we're imagining using these new techniques is in any way a significant intellectual departure from how we have been using all of the techniques in other organisms that we've had since the 1970s. And the same kind of socioeconomic implications, or nearly all the same socioeconomic implications, are aligned with the ways in which the other techniques are used. So predominantly what happens when you take a breeding approach to agriculture is that you have some kind of localized problems, say a pest. And the answer is to mass produce some kind of insecticide or some kind of insecticide producing plant. And that type of thinking is still quite well embedded in the use of gene editing technology. And then the scale at which those products are deployed lead to other potential technological implications, such as accelerating the rate of a pest resistance. Agroecology, as I understand it, avoids that kind of treadmill effect and is thus philosophically not aligned with these short-term breeding options. So my guess is that we would, and as I mentioned in my talk, we would extrapolate along the same timeline, that there is a role in coexistence, but predominantly because we have to accept that these things do exist, and they are existing at some level in different countries. The ISTAT said that if you haven't gone down that path, don't start now. Just go straight to sustainability using approaches that are aligned with agroecological agriculture. If you've already adopted those techniques, well then, wean yourself off of them, including possibly the production of new products that help you make that socioeconomic and environmental transition to sustainability.
Thank you, Jack. Someone's just posted a comment about the need for a community-focused approach to technologies, and actually Pat in a post on the chat also pointed out we should be more considering what is a good or bad system rather than technologies. But Maiwa, you pointed out in terms of the socio and economic systems, you use the phrase lock-ins to agrochemical practices or packages, and that how these packages might be developed still lock us into a particular system and a particular supply chain, and so that's what I understand, a particular supply chain, a particular set of relationships that may be incompatible with the kind of relationships that we seek in agroecology. What though if you view agroecology as a set of agronomic techniques and pay less emphasis to the socio-economic aspects or aspirations or worldview of agroecology? Because there are people who see agroecology as a collection of agronomic techniques and not have this overall worldview. How does your view about lock-in and how that will affect relationships? Does that, if there's a significant uptake amongst people who claim or say they are agroecological to some of these genetic engineering techniques, how would that affect your view, your analysis?
Not sure I understand the question, but I'm going to take a stab. So you're saying for people who do not view agroecology as a socio-ecological system, but rather as a set of agronomic practices, if gene editing would be valuable, that's not agroecology to me. I would be hesitant to espouse a type of redefinition here for the purposes of responding to a question about gene editing when I don't think it makes sense to pull agroecology out of a social and economic context, because that's precisely where we get into trouble, right? That's precisely where it becomes quite easy to separate techniques and practices and technologies from their social and political moorings. Even science itself, it can be argued, if you look at the history of the de- and underinvestment in agroecology, is a political history. So I would be hesitant to go down the pathway of talking about that. What I do think is a very interesting and problematic challenge that probably we're facing very much now is the question of complementarity? Can we, in fact, combine gene editing and agroecology? I think some of the questioners in the chat have asked, can gene editing be good for agroecology? And I think it's common to see in the U.S. some of the agroecologists, like you're saying, are open, and I think Pat was pointing to this also, are more open to gene editing because there's this idea that maybe it can help. And I think there we get into some very interesting questions about exactly what is a technology, some real philosophical issues. So there are some people that say a tool is just a tool has no politics. There are other people who say a tool is actually embedded in a politics. It is the manifestation of particular ideas and knowledge production. So I'm not going to answer these questions here, but I think you'll see some pretty firm breaks along the agroecology community, especially that I think peasant movements and organizations such as La Via Campesina, they would hold to the fact that there is a politics in technology. It is not something, a mere tool that you can take out and put into another system. And it's, gene editing can be for good or for bad, and it's not about that. So I just want to put that out there a little bit as a teaser. I know that Jack has some really great ideas in this area because we've talked at length about this in the past, and I could hear also in some of Pat's comments some very keen insights. So I'll just pause on that.
Okay, that's actually very good, very helpful. However, can I just point out that there is circulating in Europe and quoted, held up as a good thing, a piece of work about, which I think is called 10 years towards an agroecological future in Europe. And it's a piece of research widely quoted with modeling that points out how agroecological approaches can feed Europe with certain dietary changes and so on. At the start, buried away is a very clear declaration, but it is buried away by the authors of the report that they are defining agroecology simply as a set of agronomic techniques. And they make a deliberate point that they're not considering the socio-economic aspects of agroecology. Yet, that is widely presented by the agroecological movement in Europe as an example of agroecology. It raises the issue. Why I'm raising this is it requires clarification, because as governments move towards deregulation, and the question is, do we need more definition? Now, Pat made a passionate presentation about what we need and how the agroecological movement needs to engage in the debate about genome editing and deregulation. The question, I think, Pat, if you could expand a little bit, is the issue in terms of engagement and protecting, if you like, agroecology from invasive technologies like genome editing as much or as little as the agroecological farmers want to do. That requires transparency and requires labeling and regulation. It seems you can't know about seed production or plant breeding, whether they use genome edited methods, if those methods are not labeled or transparent or in some way regulated. But then there's a question as whether our side needs more clarity and more definition. So could you explain a bit more about the whole business of regulation and transparency about technology on both sides of the fence or discussion?
In the 2 minutes or so that we have left, I'll do my best. Somebody's asked a very good question on the thread, which is how do we balance the effort we put into working for a better system as opposed to against these new GM techniques? And I would argue that greater clarity amongst ourselves on what agroecology is, what it includes, what it doesn't include, etc., would be very helpful. You know, vagueness on both sides of the fence. Vagueness in the way that we all define sustainability, vagueness in the way that we perceive, talk about, and define agroecology works to feed the chaos. It works in a way that allows people to just kind of throw whatever solutions they feel might work in the moment in there. And as Jack suggested, we can often get stuck in sort of, oh, well, we'll just use this temporarily to get us over the hump. And then we never really get over the hump. We just get used to using the same old things, whether they're pesticides or genetic engineering technologies. So I am not philosophically or morally opposed to genetic engineering. I simply think it is the wrong tool for the type of farming that we need right now. And one way to contain that is transparency. To say of this tool, okay, this is a deeply transformative tool. We need to treat it with respect. That means we need sound regulation, and it has to live up to its hype enough to get through that regulation. So transparency for me is the absolute bottom line for genetic engineering technologies. It is the foundation of regulation, and it is the only thing that will allow people to trust where their food is coming from. I'm not sure I've actually fully answered your question there, but that's what I've got right now.
Okay, that's good. That's excellent. As you say, we are running out of time. They're going to ring a bell in 4 minutes. There's no time really to sum up. I just would like if the three of you would just quickly wrap up, or any comments you would like to make. But a couple of things have been missed that we've missed. One that's on the chat, maybe about the application of the precautionary principle, and the counter to that, which is innovation. So if you could just briefly talk about, the threat and the benefits, or in terms of innovation and precaution, and how we get. Okay, I know you've each got a minute to say whatever you like, but these are two things that have been missing. Jack, do you want to kick off?
Okay. Well, I'd like to just perhaps emphasize a few points made during this last hour. And those include the idea that you can take technology and consider it separate from all other human activities, using it in some kind of adiabatic chamber as a specialized tool. All technologies have a social context. All technologies have a political context. There's no separating them. And the attempt to turn agroecology into simply a more technical discussion of agronomic practice is also the same type of approach that has been taken in the risk assessment and framing of all gene technologies. It's the same pattern. So you take away the broader discourse and you put it into the hands of technical or other types of elite publics that then report back to the broader society about their value. And that is why agroecology is different from all of our other approaches. So if our goal is sustainability, it's not just to change the soil or the air. It is to create a system that when humans are involved, doesn't fail. All technologies on their own create eventually scale characteristics that cause problems. So the issue isn't a particular solution to a particular technological problem. The issue is, how do you have a system that self-regulates or heals itself in its use? And that's what's missing in the discussion about gene technologies that are being divorced from this larger scale effect, larger issue of discourse. And for that, I have to credit the other panelists.
Thank you.
I'll jump in here and pick up. It's not on the precautionary principle. Part of my work is political economy. And I think one thing that agroecology presents as a profound resistance and alternative to the status quo is in the circulation of value. So historically, as indigenous communities, as peasants and smallholders, reproduced their means of production and reproduction on the farm. And agriculture has historically been fairly resistant to the penetration of capitalist relations, but it has piece by piece peeled off portions of value, including inputs, seeds, chemicals, and so forth. And genetically modified crops are one of a long lineage of value becoming extracted and getting into the hands of what became firms and corporations. So there is no disembedding agriculture writ large from that political economy. I think that it becomes very interesting that despite the promise of CRISPR making a clean break and allowing for small firms to get in and for a wide variety of smallholder crops, that political economy constraint is so profound in a capitalist global food economy that it is only months until we see the familiar lock-in, and that lock-in is principally around control of power. And I have a hard time seeing what Dan Sarowitz calls, if you throw a tool into an existing social context, it will be a force multiplier for all the inequalities that exist. So unless we deal with that, we are going to see similar outcomes. Thank you.
Thank you. Thanks. Pat, final comments?
It's hard to know what to add to that. I think if we are going to get to a more equitable system, we need to involve more people in the conversation. That's what we said when we started Beyond GM. That's what I still believe. It's what we are lobbying for when we talk to DEFRA. We have been talking to DEFRA and the National Food Strategy about the importance, for instance, of citizens panels that can look at not just the science, but the whole package of evidence, you know, the social impacts, the public good, the ethical import of the types of technologies that we bring into food and farming. And, you know, a lot of this falls on deaf ears. And the reason is because our policymakers are looking at how can we tweak the existing system when everybody else is shouting at them that the existing system is not working and we need a much bigger transformation. So I will always continue to lobby for getting more people in on the conversation and finding ways to help people express themselves, even if they are non-experts in this field, because everybody has something to contribute.
Thank you very much. Thanks a lot for that. We are out of time, more than out of time, but I'd like to thank you three speakers. That was excellent. The chat shows that we could certainly go on. It is a conversation that is both macro and also micro in terms of you know, how things impact on the farm and in the field and so on. But I think you three have done a great job. So thank you very much. I'd like to thank the organisers, the Oxford Rural Farming Conference, Alison for helping organise the chat. That's brilliant. Thank you very much for doing that. To remind you all, please look at the survey that we posted earlier, which is our attempt to gather together views as to how agroecology what you think might be the impact of genome editing techniques on agroecology. It would be really good to get your feedback on that. So please look at the survey. And searching for a very pithy kind of end here, and struggling, so forgive me, with the analogy of the tool in the toolbox, which everyone says, you know, genome editing is just a tool in the toolbox, agroecology can just be a tool in the toolbox, and so on and so on. Begs the question, whose tool, who decides when it should be used, and whose toolbox it actually is? So thank you very much, and have a good whatever's rest of the evening, or in Jack's case, the day. Thanks a lot. Bye-bye.